in this video, we will discuss the problem binary matrix with at most k1s. So we will be given with a binary matrix M with R rows and C columns, where each column of the matrix will be either 0 or 1 because it is a binary matrix. We have to find the largest square that can be formed with center I, j with, and contains at most k1s. So you have to find the largest square with center I, j and at most k1s. Okay? There will be q queries and a single query has a different value of I, j. Okay, this is what you have to do. For example, in this case, the matrix given to us is this one, and there is only one query which is 1, 2. Means we have to find a square which contains all the ones, which contains at most k ones, not all the ones, which contains at most k ones, and whose center is I, j. Okay, so this is what we have to find. Fine. So let's consider this given test case only, which is given to us, and let's understand how can we solve this particular problem. What is the logic behind this? Okay, so first let's copy that given test case in our whiteboard. Okay, this is the matrix given to us. Okay, so if you will just see it, they're asking us that the center of the matrix should be something like I, j. Okay, and if you just see that case here, I is 1 and j is 2. So the index means the center of our square is I, j. Means it will be 1, 2. So the 1, 2 is here. This is row 1. Okay, this is row 1, and this is column number 2. This is 1, 2. Okay, so we have to find the largest square which contains at most k1s. Okay, which contains at most k1s. And if we will see this problem, the test is given here, the value of k is 9. So means we have to find the area of the largest square which has center I, j and which contains at most k1s. That is what we have to do. Okay, fine, great. So here the value of k is also 9. Here the value of k is 9. We just know this. Okay. Now the thing which we have to observe is that from this given index, how many size squares are possible. You can see that for a given index there are 4 directions, which is top, right, down and left. So the maximum side length of a square possible with center as I, j will be, what is the maximum side length? Okay, what will be the maximum size length of the square which is possible? It will be minimum of all these 4 directions, which is, let's say, top, bottom, left, the minimum of that. I am saying this because if you will just find a minimum of this, so here the top is 1. There is only one row at the top of this given center I, j. So top is 1. If I talk about bottom is 2. There are 2 rows. If we talk about the left is also 2, and right is also 2. So its minimum is something 1. Its minimum is 1. So I am saying this, it is because if you have to form a square out of this taking this I, j as a center, so you can form just a square of maximum size like this, which will be one distance from that center. You can see one distance. You cannot form a square of size like this. Why? Because here this row is upset, or it will be also covered here. Getting it on? Okay, so this is what we have to do. Fine. So this is the thing. So let me just again explain this to you for better understanding why I am saying this. Okay, for example, there is something like this. Okay, this is something like there is one more. Let's say this is a row, extra row. In this case, the minimum will be 2 because this, if this is centered, there will be 2 elements in the top also. So the minimum will be 2 only. That means we can go up to 2 rows from all the sides, and then we can take a square. But in this case, the case which we are taking, there we don't have this upper row. So in that case, we can just make if this is the center, we can just make a square with like this. So the side of the square will be 2 into this, let's say this minimum is m. It will be 2 into m plus 1. Why it will be 2 into m plus 1? Because we will go m times up, m times down. So it will be 2 into m and plus 1 for this particular cell. Let's take a different example to understand it. Okay, let's take a different example to understand the same thing. Okay, fine. So the example that we take is like, it is a, I'm just taking a quite big matrix for you to understand this thing. Sorry, it cannot be 2. It's only 0, 1, 0. Okay, for example, this is the matrix given to you. This is a matrix. It has 1, 2, 3, 4, 5, 6, 7, 8, 10 columns and 5 rows. It is a matrix of 5 into 10. Okay. Now the thing which we have to observe, for example, the center, we are taking its center as 3, 3. This is its center. 3, 3 is, or let's say 2, 2. 2, 2. So we will take 2, 2 as a center. So what is the maximum area square which we can form? Don't focus on the at most k1s. Just focus on the what is the maximum side of the square which is formed. From this center, we can, the first square which is formed is like this. Is the first square. Let's take that element. Second square is like this. And third square is like this. We cannot form another square because these two rows are not there. Getting? So to find this value, what is the maximum side of a square? For that, this is the formula which we have to. We have to take the minimum of top, bottom, left, right. So if I will just form the minimum of, so its top is 2, its left is 2, its bottom is 2, and its right is something 7. So its minimum will be 2. Means there will be the maximum size of the square possible is 2 into 2 plus 1, which is 5. Okay, so you can see that this is the square which is here. It was there and whose size was 5. 1, 2, 3, 4. This is how we can find that what will be the, don't focus on the at most k1. Let's focus on the maximum size of the square which is possible from with that center. Now the thing is, now we have calculated that what is the maximum possible size of a square which is possible from the given center. Now we have to observe, so basically the logic behind solving this thing or to calculating the maximum size of a square is this, that the square which will be possible as our answer has its side length between 0 to this max. Either the side of that square will be 0 or this max. So the size length of that square which is possible will be always be between the 0 to m. Obviously, because the maximum size of the square possible is m only. So the size of our square, which will be our answer, which will contain at most k1s, will be between 0 to m. But now thing is, how can we calculate the number of ones in a particular sub matrix or a square sub matrix? So for that we will use the concept of prefix sum. So here, in case of this matrix, we have a modified version of prefix sum. We will understand it. It is a something of DP concept, a dynamic programming concept. So we will understand it. Okay, how we can solve it. So let's see that how we are solving it. Okay. So for example, this is the thing given to us. Okay? This is the thing given to us. So here what we can do is that just a minute, guys. So we can just create a one more another the same matrix of the same size. Okay, we will take another matrix of the same size. Let's take it like this. Okay, and here we will modify this matrix. Let's name it a DP matrix, or let's say count DP matrix, okay, because it is doing the count of this. Let's name it count DP matrix. Okay. Now what it will give, a cell in that DP matrix will tell us the number of ones if we will start from the 0, 0 cell to that particular cell. For example, this will contains number of ones present in this particular area. This matrix will show us the number of ones present in this particular. Getting? This will show us the number of ones present in this particular sub matrix. This is what we will do. This is how we will just create this particular given DP count. So first of all, we will perform the same prefix just like we do in the prefix sum array. Similarly, we will do here. First, we will do it row wise, then we will do column wise. So when we will do it row wise, it will be something like 1. It will be 1. Then after 1, it will be again 1. Means it means that till here there are 1 ones. Here you can see. Here it will be 2. Why 2? Because till here there are 2 ones. Here it will be again 2, and here it will be again 2. Because here are also 2 ones and 2 ones here. For this, here it will be 1. Here also it will be 1. Because here we have 1s. Here it will be 2. Here it will be 3. Here it will be fine. Similarly, here it will be 1, 2, 3, 4, 5. And here it will be something like 1, 1, 1, 2. This will be the prefix sum on each row. Then we will apply the prefix sum on this particular given matrix on each column. So when we will perform the prefix sum on each column, we will get a certain value. Okay, let me just perform the prefix sum and let me just write it here. Okay, just below this. It will be 1, 2, 3, 4. Then it will be 1, 2, 4, 5. I will explain you how I am writing. I am just making prefix sum on each column. Okay, then it's 2, 4, 7, 8, and then it is 2, 5. I'm just writing 2 and 2 plus 3 5, then 3 plus 4 5 plus 4 9, and then 9 plus 2 11. Okay, then it will be like 2 6 11 30. Okay, this will be our count DPL. Here you can see, for example, if we are taking index 3 comma 4, index 3 comma 4 is something like 3 comma 4. This will be there, or we can just take 2 comma 2. So 2 comma 2 will be something here. It is 2 comma, which is 7. So if you will take a sub matrix, okay, if you will take a sub matrix and you will find a number of ones present in that sub matrix. So let me just take a sub matrix which will be up to 2 comma 2 only. So this is a sub matrix which is up to 2 comma 2. If I will just count number of ones, so here are 1 2 3 4 5 6 7 ones there. 7 ones are there, and here you can also see is 7. It will tell us the number of ones if we start from 0 comma 0 and we will go up to this sub matrix. So here we have counted this, we have calculated this count DP array. We will discuss about the code solution also. We will discuss how we can form this count DP array, basically count DP matrix. Okay, now but here this matrix will tell us about only the number of ones present from 0 comma 0 index to that I comma j index. But for example, we have to find the number of ones present in this submatrix. So how can we find? So to find the number of ones present in this submatrix, we will take the whole matrix up to this I comma j. Then we will subtract this one and this particular submatrix. We can do this now. And because you can see that this element is subtracted 2 times, we will again add this given element. That is what we will. So for that there is algorithm. When we will code it, we can. So here we have learned that how we can find number of ones present in a given submatrix without every time iterating from that index, because that is a brute force solution, that for each and every submatrix we are just iterating through the submatrix. But here, just like we do in prefix sum, for example, we have to find the sum of elements in a subarray, we use prefix sum technique. Just like here we are using prefix matrix. This is what we do. Now let's move towards the code solution and let's understand, because while writing the code we will also understand how we can solve this given problem. Okay. Now let's move towards the code part. So first of all, what we will do, we will create a count DP matrix, okay, where we will find the prefix sum of the given matrix. Okay, so for that, let's declare a 2D array and let's name it count DP. Okay, so the size of this matrix will be equal to the size of our given matrix. Okay, so which is R comma C only. Now what we will do, for now we will just initialize with this count db matrix with the value 0. Okay, so using the memset function we will initialize it. So it will be something like count dp, the value will be 0, and it will be for all the values of size of this count dp. Okay, now what we will do is that we have to pre-compute this. Okay, so the first cell of this count dp matrix will itself the first cell of a given matrix. That is okay, I think that is okay for you. So the first cell of this count dp will be equal to the first cell of our given matrix, because obviously the number of ones at the first cell will be equal to the, if it has a 1 then it will be 1 only. Fine, that is the thing. Now first we will perform that prefix sum operation on all the rows, then we will perform that prefix sum operation on all the columns of that given count dp matrix. Okay, so great. So for that let me just write a function. Fine, so which will be something like that we will perform the first on the whole row and then on all the columns. Fine, so it will be something like this is the statement. So this is for all the columns, all the rows. Here we are just starting from the row number 1 to row number r, and then we are performing the prefix sum operation on all the rows. So it is just something like count dp of I comma 0 will be equal to count dp of I minus 1 comma 0 plus matrix value at I comma 0. Okay, that will be the only thing. Now the similar thing we have to apply on all the columns too. The same thing we have to apply on all the columns too. Okay, so for columns also we will apply the same thing, and that will be the prefix logic. Okay, and it will like this. It will be like this. This is what we have to do. Okay, that count dp 0 comma j is equal to count dp of 0 comma j minus 1 plus that particular cell. Okay, that will be the prefix. Now again, now we have to, what we have to do is to find that for each particular cell, getting for each particular cell what will be the number of ones present. So for that what I have told you was we have to subtract some another one. Okay, so for that, to basically compute this thing, we will create some more operation. So this is an operation which is quite confusing for you guys. Here what we are doing, we are just iterating through that count dp matrix. Okay, for each and every cell. Then what we are doing, so for each count dp we are taking that given index. Here it is, sorry, it is m. Okay, it is, the matrix name is m here. Okay, so it will be that particular cell that is given to us. Okay, plus its cell at the top. Okay, plus its cell at the left minus its cell at the diagonal up. Okay, that is what we are doing. And this is what we have to observe. Okay, this is what we have to observe. Now just understand that what it is doing. Let's understand. Okay, let me just explain this thing in the whiteboard. Okay, let me first just copy this given code so that we can just understand this thing and what this piece of code is doing for us. Okay, so what it is doing for us, let me just write that code here. Okay, yeah, so it will be something like this. Okay, now if we will just continue it. Okay, and if I will just perform this in the given test case, or in the given matrix which was given to us in the first case, which was like this one only, I think. Yeah, if we will just apply this here, so it will be something like just a minute guys. Yeah, great. So now what we have to do is that we'll just place it here. Okay, we'll just place it here. So what it is doing is, for example, let's take just take example of I comma j as 2 comma 2. Okay, 2 comma 2 is a good thing for us. Or let's take 2 comma 3 also. 2 comma 3. So 2 comma 3 will be this particular index. So what it is doing, that the value of count dp is m I comma j, matlab means m 2 comma 3. So m 2 comma 3 will be 1. So it will be 1 plus dp count dp of I minus 1j. So I minus 1j is something here. So count dp means it will store the number of ones in this given sum matrix. That is what we have stored using prefix function. So there are 5 ones, so it will add 5 plus. Now it will add this thing, which is number of ones present from here, okay, ij minus 1. So it will be 1, 2, 3, 4, 5, 6, 7 plus 7. And we have to subtract number of ones present at this particular segment, which is I comma j Jacob with this. So here number of ones present are, you can see, 4. So 4 will be subtracted. So the total count which we will get is 13 minus 4. So it will be 9. It will be 9. You can see. And if you will just check it, let me just clear it to you. If you will just check it, that for this particular, because that was a cell which we have considered, which was 2, 3. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. This is how we are calculating that how many ones are present for that particular submatrix given to us. Okay, great. Now what we will do is that this is what we have got it now. Fine. So now we will just move towards the next part of this code segment. Okay, that is solving for each given query. We have to solve for each given query, and for each given query we will find a max distance which is possible. I put it that the max distance which is possible. Okay, the value of the max size of that square which is given, and also we have to store the answer, and which we will return it in vector. So let's take a vector res where we will store that answer. Okay, great. Now what we will do is that we will have a for loop for queries. So let's take it as q, and let's do it until q only, because q are the query which we have. Okay, and then what we will do, then we have two components now, which will I comma j. Okay, so I comma j will be basically will be stored in this given array qi and ji. So we have just extracted that. Okay, now what we have to find the minimum distance. So as I told you, the minimum distance will be the minimum of top distance, top, left, down, and right. Okay, that is what we will do. So for that, I am just writing a equation. Okay, that is an equation which we will do here, Okay, so just a minute. Okay, so this is the equation which we have here. Okay, which is a minimum value of this I comma j and this r minus I minus 1 and c minus j minus 1. This is basically the right, this is down distance, and this is right distance. Because for a cell, if I talk about the cell, for this cell, the number of rows present at the top are I, number of columns present at the left are j, and if we talk about here right side and downwards, it will be calculated by this particular two expressions. And as I told you that the maximum, this is the min value of this, and if I will just told you the maximum size of the square which is possible, it will be equal to 2 into k plus 1, or it will be basically 2 into mid of this plus 1. That will be, but that we will find later on. First we will just count, because that is the maximum size we know, that this will be the maximum distance which we can move from that center of that square. Okay, so we will just apply a binary search from 0 to this particular value. Okay, so for binary search we will have some variables. Obviously the upper bound and lower bound of our binary search, it will be L is equal to 0 and U will be equal to this value, which is mean distance only. Okay, and we will have answer variable also, which will be initialized by -1, because first we will start with -1 only. That is what we will do. Now what we will do, we will just create a while loop, and that while loop, what we will do, we will just use it like L is less than equal to U, just a normal binary search algorithm. Okay, yeah. Now what we will do, we will find its mid, and we will find the x and y coordinate of the sub matrix which we are taking. So the mid value will be the just L plus 2 by 2, and x1 comma y1 and x2 comma y2 will be the basically the coordinates of our square which we are taking. So let me just explain this to you. This is a quite confusing topic. So what I am doing here is that I am just saying that if we have to consider I comma j as our center, and let's say I am saying that we have to take mid number or m number of cells at the right, at the top, at the left, and at the bottom of that cell. So if I comma j is the center of that square, if I comma j is the center of the square, and a square is something like this, let me just Square is something like this. You can say that from this center, the square distance is 1. So what will be the coordinate of this end and this end? Obviously, if this coordinate is 2 comma 3, or it is something like, I think, 1 comma 3, it is 1 comma 2. So the coordinate of this will be using this formula, which is x1 will be I minus mid and x2 will be I plus mid. Y1 will be j minus mid and y2 will be j plus mid. Mid is basically distance from the corner of the square which we are considering and the center of the square. We have to just make use of that count dp matrix which we have created. So here it is. We are just using it. Fine. So the count will be the whole matrix we will take from x2 comma y2. Then as I told you that, because let me just again explain this to you. Okay, let me just again explain this to you. As I've told you now, that if we have to find, yeah, so I told you that if we have to find the let's take this particular submatrix, but what you will get the number of ones present in this whole matrix. So you have to subtract this particular submatrix ones and this particular. That is what we are subtracting from. Okay, that is what we are subtracting from. So that is what we have done here too. That we have first taken this count, then we have subtracted this thing, and then we are also adding one thing. What we are adding? Let me just explain this. Because you can see that we have subtracted this segment of the matrix 2 times, but we want just it subtract 1 time. So we will again add that thing, just like we do in, if you just know about that union and interaction logic which we have studied in basic mathematics, that union and interaction, that is what is discussed here. Okay, that is what is discussed here. Fine, great. Now again, because as we know that the number of counts which should be possible in that submatrix should be less than or equal to k. There should be at most k number of ones. So we will just come check for that thing too, that there should be at most k number of ones only, not more than that. Okay, not more than that. So for that, what we will do, we will just take a condition here, which will be something like this, that if count is less than or equal to k, then we are considering it as an answer. Means, yeah, we can take that particular square as our main square, and then we will find the maximum of this answer, because we have to store the maximum. Okay. And just like in binary search, if the count is less than k, so we will update the value of L, that yeah, we can move forward, we can take more ones, and else we can just update the value of U, that yeah, that is not, we have to decrease the size of our side of the square. Here we are increasing the side, here we are decreasing the side, just like we do in binary. Okay, so this was the binary search algorithm. Fine. And at the last, if there is no such square present, then the answer will be -1, 2. Then the answer will be -1 itself, obviously. So if the answer is just -1, here we can write that if answer is -1, then make that answer is equal to 1. Okay, then make that answer is equal to 0. So not means no such subsquare is possible which has at most k ones. Okay, and then what we will do, we will just push that answer. We will just push that answer into our res vector, and then after each and every query, we will just return this res. So this is what we have done. This is what, now let's run this particular program. So there is some error. Yeah, there was an extra column, no problem. So it is, so you can see that all the test cases are passed. Now let's talk about the time complexity and space complexity for this given program. Okay, so as we know that we are just traversing, traversing through the given matrix. Okay, so traversing through the given matrix will take our time complexity of r into s. R is the number of rows, and c, r into c. So if we talk about space complexity, so space complexity will be simply O into r into c. Why? Because we are just taking a count dp matrix as our exercise space. And if we talk about time complexity, so we are just iterating, we are just traversing through the matrix, that is okay, but we are also performing binary search. Okay, on q queries. Each binary search is taking log of min distance time, because we are performing binary search from 0 to min distance. So that is why this will be the time complexity of our program. Here you can just find that we are just performing binary search and we are just doing that thing. Okay, here is the how we are iterating through the whole matrix, and here we are performing this binary search, which will take log of min distance time, because it is from 0 to min distance. This was the problem. So I hope you have got this problem. If this problem is clear to you, please hit the like button. Okay, please comment, share this video with your friends, and